All right, we have another circuit here that has two unknowns that we're trying to solve for. We don't know what the EMF for this battery is, and we don't know what the value of this resistance is. But we do know that a 1 amp current is going to flow from A to B, and a 10 amp current is going to flow from E to D. Looking at this circuit, we can't reduce it in terms of series combinations of resistors, because the quick inspection tells us there's a 10 amp current here, 1 amp current there, there'll be an 11 amp current there, so none of the resistors have the same current through them, so they can't be in series. And it's also not obvious that any of those resistors are actually in parallel with one another. So we can't reduce this circuit piece by piece, replacing resistors with their equivalent series combination or their equivalent parallel combination. But what is still true is we can use Kirchhoff's loop rule and Kirchhoff's junction rule to develop a set of equations that will allow us to solve for the unknown EMF for this battery and the unknown resistance. All right, so looking at this circuit, the loops I can pick from, there's one that goes A, B, C, F. I could have a loop that goes E, D, C, F. I could have a loop that goes A, B, C, D, E, F, back to A. So out of those loops, to solve for an unknown EMF and an unknown resistance, I want to pick one loop, A, B, C, F, that is just going to involve one unknown, and then I'm going to pick a loop that goes E, D, C, F. It will only have one unknown, the resistance R. All right, so let's start with our first loop. So B, C, F, back to A. I will have voltage drop across the resistor, the 6 ohm resistor. So it's a voltage drop. So I'm going in the direction of the current. So minus 1.00 amps times 6.00 ohms. I'm going to have a voltage drop. So it's going to be 1 amp plus 10 amps. So I'm going to have minus 11 amps times 4 ohms. I'm going to go through the 125 volt battery from the negative to the positive terminal, so that is an increase in voltage. And then I'm going to go through the EMF for the second battery from the positive to the negative. So that is a drop by the EMF. So let me simplify this a bit. I'm going to move the EMF to the other side. I'm going to have 125 volts. And I'm going to have a drop of 6 volts and a drop of 44 volts. So that is going to tell me that the EMF of the second battery has got to be 75 volts, because it is 125 minus 50. All right, so we've solved for what that EMF is. To solve for the unknown current, or the unknown resistance R, let's look at the loop that goes E, D, C, CF. And again, I'm picking that loop because the only unknown that's going to come about in applying Kirchhoff's loop rule is the unknown resistance. I know the current, I know when they join at the junction C, it's going to be 11 amps. I know that resistance, I know the voltage of that battery. So the only unknown is the resistance R. All right. So I'm going to have a voltage drop because I'm going through the resistance R in the same direction as the current. So I'll have a minus R times 10 amps. I'm going to have a voltage drop of minus 4 ohms times 11 amps. And I'm going to go through this battery from the negative to the positive terminal. So that is an increase of 125 volts. And to conserve energy, that has all got to add up to 0. So I want to take the unknown, the term with the unknown R, move it to the other side. So I'll have on the left-hand side will be 125 volts minus 44 volts. It's going to equal 10 amps times the unknown resistance R. 125 minus 44 is going to give me 81 volts. It's going to equal 10 amps times R, and then divide both sides by 10 amps. So the value of the resistance R has to be 8.1 volts per amp, and a volt per amp is an ohm. So we've solved for the unknown resistance, R. So problem's done. If you have a circuit where you can't simplify it by replacing resistors with equivalent parallel and series combinations of resistors, then apply Kirchhoff's junction rule for how currents combine in a junction or split as they leave, and Kirchhoff's loop rule to account for how the voltage increases or decreases as you go through the loop. And you want to pick your loops, if you can, such that each loop is going to give you an equation with one unknown that you want to solve for. And sometimes that's not possible. And if that's the case, you're going to wind up with a set of coupled equations where an unknown appears in more than one equation. So you have to go through and eliminate unknowns in your system of equations until you get a solution for all of the unknown terms.